Good evening, everyone. I'm Anshul Jannumahanti. I know it's been a long day, so just sit back and relax the talk. So, I am Anshul Jannumahanti. I'm a computer science student. I am going to enter my third year this fall. I am deeply interested in software engineering, Python, and backend systems. My topic for today is debugging Python in production and practical techniques beyond print statements. Now, before we go beyond print statements, let's understand how these print statements are used in debugging. So, over here, I have a code snippet. I have a screenshot and the output just to save our time. So basically, there are 3 print statements. And when I run this code, only 2 of them get executed, which is program started and the user found. The third print statement did not get printed because there was an error, which is 10 by O. And this is how debuggers used print statements to find out where the error has occurred in their codes. Now, this is quite easy, it's reliable, and it's quick. Okay, yeah. But these are only used in small systems because there are small projects, there is only one single developer, the small code base, and it is easy to debug with print statements. Now, when it comes to production system they have like multiple users, multiple servers, multiple requests, real money is involved. Here, your failure matters. For example, for small projects, it can be anything like a student attendance tracker system. Not multiple, it has only like few users at the same time. But production system, it can be a social media app or food delivery app where you're paying for the food, you're paying to book a ticket, or you're using your social media to post something whereas someone else is doing something other thing. So how does production debugging work? Production debugging is also known as modern debugging. Engineers have a system to deal with everything. So this system consists of logging, tracking, tracing, and monitoring systems. So let's start with logging. Logging is like a digital diary. It holds and records your important events, errors, application IDs, user IDs, request IDs, and all that. Here, from my screenshot, you can look that it shows the time of the error, what was the error, and the user ID error. For the same thing, if you used print statement, it would have shown payment success for user ID 1, payment success for user ID 2, and all that till payment failed user ID 182. So logging is used to get an optimized output. It saves your time, it shows timestamps, severity levels, user IDs, request IDs, and server information. Now, logs can tell us something failed, but we still need to identify exactly where the crash happened. That's where tracebacks and exceptions come into the picture. Tracebacks, it shows a sequence of function calls that led to an error in a Python program. And exception is a kind of error in Python during execution. Whenever Python catches an exception, it stops executing the code right at the moment. So over here, in the screenshot, you can see there's a small code, and there's a traceback most recent call last. So this is a message saying, okay, so there's a sequence of things which went wrong in your code. First is the divide function, which instigated the error. And then there is return 10 by O, which is the error. So it identifies the exact error location, and it shows the cause of the crash. So this helps in debugging and reduces the guesswork of the debugger. So there are common built-in exceptions in Python, which can be zero division error, file not found error, type error, value error, index error, key error, or name error. Tracebacks and exceptions are used to prevent program crashes, provide meaningful error messages to users, and to handle runtime errors gracefully. So, monitoring systems. Oh, my bad. Sometimes monitoring shows that the system is unhealthy. Okay? Now, finding errors is important, but in production system, engineers also need ways to continuously watch the system health. So that's why monitoring system kicks in. It is a process of continuously tracking the health and performance of an application or system. For example, a monitoring system tracks CPU usage, memory usage, server health, and all that. For example, if there is high CPU usage, the engineer restarts overloaded services, he scales the servers. If there is too many errors, he rolls back the bad deployment and inspects logs and tracebacks. If the API slows down, he optimizes the database queries and uses caches. And if a real-world example of a server suddenly reaches 95% CPU usage, monitoring system alerts the engineers before the application crashes. So that's when the engineer restarts the overloaded services, scales the servers, and optimizes the slow code. Now, Python allows you to use several monitoring tools for this. The most popular are Prometheus and Grafana. Prometheus is a monitoring and alerting toolkit, and whereas Grafana is an open source web application, which visualizes the data in forms of graphs and traffics and checks, just for the engineer to get to know about the data even more in a way. I believe Sentry is also a very popular application right now for monitoring, and I think there is a stall downstairs, so please go visit that. And tracing, yeah. So sometimes monitoring shows the system is unhealthy, but the actual issue could be hidden deep down. And tracing helps engineers follow request step by step. So in tracing, an engineer can follow the requests in an application, and he can identify where the error is actually being occurred. For example, let's take a food delivery app. There's user, there's an API, there's an authentication process, there's the database, and there's a payment server. For example, if there is some failure in payment, so this tracing helps the engineer to identify where the actual problem is occurring. Is it because API slowed down? Is it because authentication wasn't successful? Or was that because database crashed? So that's what tracing helps. It helps the engineers to identify where the request went, which services slowed down, and where the failures happened. Now, tracking and exceptions are used in a code level, whereas tracing is used on application level. So this matters because apps, for a normal user, app is just one thing. But for us as engineers, an app is a group of several services and not one giant program. And to debug each service completely, it is harder. That's why we use these systems. Now, observability is just understanding of the systems we just came across at a level. And for example, this modern production system that says it's huge, distributed, always running, and constantly changing. But observability helps engineers to investigate failures, understand performance issues, detect unusual behaviors, and debug faster. Let's take our food delivery app again. Suppose there is an, suppose there is a payment failure again. So what does monitoring alert? Monitoring alert finds out, it collects the data and finds out there is a sudden increase in errors. Now the engineer checks the logs and finds out that the error is mostly in payment. Then he uses traceback analysis and finds out the payment, where the payment failure is actually happening. Is it because due to the API slowed down, or is it because the database crashed? Then he'll request for tracing, and when when he identifies the service failure, he fixes and deploys it again. So that was my talk. Any questions?
Hi. So a lot of times I found like Grafana showing a sudden memory spike, so that could be a memory leak. But that thing isn't running in production, but you can't like attach a profiler or something. So how do you work with a sudden spike and in memory and try to debug? Do you add like in production systems, you can't like maybe sometimes it's very hard to recreate that locally or in other environment, because it could be something related to a UGC, user generated content, or something like that. So what's your take on this?
So basically, if there's so basically you're coming across a CPU usage failure, right?
No, memory usage.
Memory usage, okay, memory usage. Then are there any memory leaks of any kind? You have to first fix the memory leaks.
That's my question. Like, how do you debug what's like if you go to a NodeMon Grafana monitor and you see like a sudden, like you showed that there is a sudden CPU spike, but there can be also a sudden memory spike, like that the memory is not going down, so that means there can be a memory leak. But so in that case, is what do you find a way to check things?
At that time, I usually clear the unused resources which were there, and that helps me out.
Okay. Thank you.
You mentioned doing traceback analysis, but how, or what tools or instrumentation are you actually using to get that traceback, right? If your server is logging the error message, are you logging every function call as well in order to be able to perform that analysis? How do you actually do that?
Yeah, we do use the logging for every function.
You log every function?
Yeah.
Okay. Okay.
Yeah, thank you.